there are three factors that affect how substances transport, whether a substance can transport across a membrane or not, right? And these factors are, okay, so what are the factors? Number one, anyone remembers? Thank you, polarity. So polarity or charge. These are things that will affect whether it can pass through the membrane or not. Because there is this thick layer of fatty acids that we call the hydrophobic core. It's a very thick barrier. Alright? Number two, what's the second thing that can affect whether a substance can pass through a membrane or not? Size. So small things can just slip through the cell membrane quite easily. Because these phospholipids are constantly moving. There won't be gaps here and there, things can pass through, they are small enough. Okay? The third thing that can affect the direction of where the substance will move will be this thing called concentration. Okay? This one affects the direction of transport. What do I mean by that? I'm going to demonstrate to you. First, let's say we have something that's high concentration and low concentration here. Okay, I'm going to represent the concentration by dots. So here is a high concentration of something that's dissolved. Here is a low concentration of something that's dissolved. Okay, I'm going to do the reverse over here. So let's say there's low concentration of this particular substance in blue. And here is a high concentration of the substance. Whoa. Okay, just very quickly buzz with your neighbor. Can you tell me what's the direction that the substance will flow in this scenario and in this scenario? Will it be from outside in, inside out, or outside in, inside out? Quick buzz at your table. Okay, morning exercise. Okay, a quick morning exercise. For this one over here, will this substance move from outside in or inside out? Outside in. Why? Right, okay. So if we listen to Shi Qi, she says, diffusion takes place always from an area of high concentration to low concentration. So it should move inwards. Okay, then we'll take the other as a reverse. Okay, so the other side, it should move outwards. So whether a substance moves in or out also depends on this third factor, concentration. Whether it can pass through the membrane or not depends on number one and number two. The direction is dependent on the concentration. We refer to this as simple diffusion. So let me add one more layer to this. We call this simple diffusion. Okay? In the event that a substance cannot pass through the membrane by itself, and it requires the help of a protein. I don't know if this can stick here. Yes, okay. Okay, so it requires the help of a protein. So let's say, oh, I have high concentration here and low concentration here. Substance will move through the protein inwards. We refer to this form of diffusion that requires the help of a protein. We call it, you still remember, starts with an F. Okay, thank you. So the word is facilitated diffusion. Facilitated diffusion. Enough? Yes. Sorry? What? Hey, what? Salah. Okay. Thank you, thank you. No. you. Thanks for letting me know. Hey, you all be careful on the side. Later I'll mop it up while you start your practical. Okay? Oh, wow, it's got to be careful. So last but not least, we also talked about water molecules yesterday, right? We learned that water can move through the cell membrane. So here's some water. And lots of water. Okay? What do we call the process of water moving across the membrane? Okay, and we call it osmosis. Osmosis can occur without or with a protein. Yeah? It can occur with or without a protein. With the protein, it's just much faster. Without a protein, it's slower. So osmosis can occur with the protein. With the protein, it's going to be much faster. Without, slower. Okay, so that was a quick recap of yesterday. The last thing I asked you yesterday was, how do ions move through the membrane? Okay, I let you choose. Choose between simple diffusion, facilitated diffusion, or osmosis. Which method do you think ions will use to get across the membrane? Ions are charged. Okay, bear that in mind. Okay, a quick buzz with your table mates. Which method do you think ions will take through the membrane? Simple, facilitated, diffusion, or osmosis? Okay, then I'll seek your response in a while. Ions. Okay, which one will ions use? Okay, please have a discussion. Yeah, which one will ions use? The more you don't talk, the more I'll ask you to talk in front of the class. Okay, ready? So, ions will take which pathway? Zixuan? Okay, so the choice has been made. Facilitated diffusion for ions. Then my next question is why? Why would ions use this particular method? What about its property? Okay, so one step forward. Zixuan says that ions, if she used the simulation, make use of proteins, right? So therefore, it's facilitated diffusion. Okay, good. Okay, next level. Why do ions need to use proteins? Why can't they just go through the membrane by themselves? Okay. Why can't ions just go through the membrane by themselves? Why do they require protein? So let's say I'm working with Na+. Anyone would like to try? Yes. They are? Okay, close. They are not polar. Okay, when we look at an ion, you see this plus symbol over here, we say that it is charged. It is fully charged. Okay? So ions are charged. So what if it is charged? Very good, huh? We are building up. So what if it is charged? Okay, remember, we look at the heads of the cell membrane. It is hydrophilic. Remember that? Yeah, it's hydrophilic, the heads. So these ions will very much prefer to stick onto the surface of the membrane. Right? They are charged. The surface of the membrane is hydrophilic. They will just stick onto the surface. That's one thing. Number two, this is a hydrophobic core. They don't mesh with each other. Something that's charged and something that's hydrophobic, they don't have a good relationship with each other. It won't pass through. That's why we require the help of proteins to be able to pass through. Okay, so that's the last thing we're looking at for transport across membrane. We looked at what can or cannot pass through, and it depends on the polarity, charge, and the size. Ions are really, really small, but because they are fully charged, they will very much prefer to stay on the surface, and they cannot interact with the hydrophobic core, okay, even though they are very small. So, how can I check if you understand, or how can you check if you understand this particular part of the lesson? One way is that I can throw you a random biomolecule or random substance, and then I ask you, which method of transport do you think this substance uses? That's how I can check, how you can check your own understanding. Shall we try one? I'm going to give you one random substance. You tell me, based on these three factors and these forms of transport, which one is going to use. Okay, we try one, huh? I'm going to give you a new substance. This substance is nitrogen gas. Okay, nitrogen gas, N2. If I were to draw this chemical formula, is N2, like that. Quick one. Okay? Check the three factors. Which form will you use to get in and out of the membrane? Okay, can you buzz with your neighbor now? Nitrogen gas. Yes. Yes. Okay. And also it doesn't want to interact with the core. So there are two factors at play. Okay, ready? Nitrogen gas. Which method will it use? Oh, yes, Henry? Thank you. Okay, simple diffusion. Why? It's not polar. Other than that? And it's small. Okay? Okay, so that's the ideal. That's how we think through this process. Can throw you any substance. The skill to pick up is apply what you've learned. Polarity, size, then you apply. Which method best applies? Alright? Today we're going to move on to the next part. We're going to look at number one. Station 1, those on this side. We're going to look at how really big proteins are transported in and out of the cell. Right now, we've been working with rather small things. How about big proteins? How are they going to be transported in and out? The word you encounter today, the new word, is exocytosis. If you go into Google Classroom, you will see this. Can everyone go into Google Classroom? Can you go under the topic of cellular organization? Under Google Classroom Cellular Organization, you'll find CA 3.1 submission. Okay, I'd like you to click on that, and inside you will see a few materials provided to you, clues to help you out for today's practical. Okay, this is what you should see in your Google Classroom. Have the same page. Yeah, okay. So first you'll see a video on the cell membrane, and it says exocytosis, endocytosis. For groups on this side, like this side over here, please watch this video as a clue as to how you're going to model what you're supposed to model. Okay? Okay, so some instructions are, everyone on this side, you will find a bag of phospholipids. I'd like you to use those bag of phospholipids to create an animation. Okay, one person on video, the other two will help to create the animation. Once you created the animation, I would like you to put it into the Padlet link over here. What are you supposed to animate? Hold on. Number one, you're supposed to animate the cell membrane. And number two, you're supposed to animate the process of exocytosis. I'd like you to try using this particular video provided. Yes?
Is there such a thing as facilitator?
Facilitator what?
Osmosis.
Right, okay, so the one with the protein, right? Okay, I tried to search before, there's no such thing as facilitator osmosis. Yeah, but actually it's kind of like facilitated, right? Okay. Next, those on this side, we're going to investigate what affects osmosis. Okay? On your table, you will find two containers, one with A, one with B. Can you see one solution A, one solution B? Your goal for today is to follow the instructions of the practical, and by the end of it, you have to figure out what exactly is solution A and what exactly is solution B. I provided you a clue. This clue is this simulation here. Okay? This is the clue that's given to you. With this clue, you have to figure out what solution A and what is solution B. Okay, are you ready? Okay, you will work as a team of 3. After half an hour, I will ask you to make a swap. Okay? Ready? Yeah, so stand by, everyone on your feet. Everyone on your feet. Yeah. Funny out. Everyone on your feet. We're going to begin. You have half an hour for each station. I will be walking around to observe how you complete the task, and I will help you out along the way. Okay, ready? Okay, your first half an hour starts now. Sorry, I have to shut the tab.